So it's a challenge whereby we ask individuals within 4 years of graduating to submit a design that solves a problem. And it's a really, really wide brief. And the purpose of the Dyson Award is to try and highlight fantastic innovation from all areas around the world. And the James Dyson Foundation operates, as I said, in all of these various countries you can see here. So we have submissions from the James Dyson Award, not only from the UK, but also from Australia, America, and all of the regions that you can see within here. We have an international winner, and we also have winners for each of these different regions as well. Now, hopefully you've all kind of understood a bit about prizes for the James Dyson Award. So every year, the 27 national winners receive £2,000 if they win within their region. And we highlight as well the 54 runners-up. So even those that don't win quite often get a lot of visibility on the designs that they've created. From this, we actually generate a top 20 shortlist. And from that, we pick out the top winners and the runners-up as well. And we identify the winners that receive £30,000, and then the runners-up as well receive an extra £5,000. However, this year, we've implemented a new award, and we're wanting to try and highlight a sustainability winner. So it's really important here that these awards are separate. So some awards are some designs are fantastic in terms of sustainability, but some of them are inherently not. And what we want to try and do with this section of the award is highlight an international winner, but also be able to talk about sustainable design, given its importance in the way in which we design products at the moment. So let's talk a little bit about the brief. With the James Dyson Award, we want you to design something that solves a problem. And as part of this, we want to see some really good iterative design work that's gone into not only identifying a problem, trying to solve it, and understanding where your problem requires a high level of resolution. So you take a solution and then you iterate it and make that design better and better and better to come to your final solution. We've got some examples of some previous winners, which hopefully you've all seen. So some of these are from the 2019 finalists. You can see that the top left is AFLO. This was actually a runner-up for the International Awards, and it's an AI-enabled asthmatic trigger detecting device. And it links to an app so that it can collect data so that individuals are more aware of what actually triggers their asthma and hopefully help with some of their habits and behaviours. We've also got some examples of some international winners. So starting from left to right, Marinatex was the 2019 international winner. They developed a new form of bioplastic made from organic waste with the intention of making this applicable to multiple industries. Now, this is one of the most recent award winners, but the one in the middle is Mum Incubators. They were looking at targeting the problem of incubation of young children in various countries around the world. So typically, incubators are relatively large, chunky, very expensive pieces of equipment. And what he wanted to do in this particular design was make it far more compact, far more simple, and far more portable. And in fact, the Mum Incubators and the winner of the award of that year, 2013, was the current designer has taken that concept and is currently putting it into industry. So he's working as part of his own business and a startup to launch this. And he really used the James Dyson Award as a real pivot for his design and for his business. He generated quite a lot of interest, and he was able to use this submission to spearhead his business going forward. Now, Petit Police on the right was our 2017 UK winner. And although the individual only won for the UK award, actually this design is currently within manufacture and is being sold in various countries around the world. So we've got some really nice examples of where the James Dyson Award is not only encouraging a winner, but we're also trying to get individuals to innovate and take their designs into industry and into the real world. Now, I'd quite like to give you a bit of an overview about engineering at Dyson and how that influences a lot of the award in itself. So at Dyson, we have roughly 6,000 engineers and scientists globally, and they work across research, design and development. And we refer to this as RDD. And so our RDD is our hub of our creative ideas and concepts. And within this area, we take ideas, we iterate and develop them, and we come up with concepts and products. Now, within my time at Dyson, I've been here for around 4 to 5 years. I went to university at Loughborough and then went away and did a placement year within a prototyping consultancy. I then came back to do my final year before then joining Dyson. And within that time at Dyson, I've worked within the prototyping industry and then have spent the last 4 years working as an engineer designing the products. So what I would like to really encourage as well, for those of you considering placement years, I really encourage them, and I think they were fantastic. And if you have any questions about those at the end, also feel free to bring those up. Now, this is some of the examples of some of the products that I've worked on in my time at Dyson. So for those of you who have seen this product, this is a purifier humidifier, and I work in the environmental care category, so looking at healthy air, healthy homes. And really, all of our products that we launch, So really, all of our products that we launch all come down to this iterative process that all stems from James's very first technology. And this was the Cyconic vacuum cleaner. And with this product, he found it very frustrating because his current vacuum cleaner, which was a Hoover Junior, generated suction. And as the bag filled up with particulates and dust as he vacuumed his home, the bag clogged up and there was a huge loss of suction. And it was this frustration that actually drove James's first innovation. And to do this, what he did is he used cardboard and some really low resolution prototyping techniques, things that we very much use in our day-to-day role at Dyson. And he built that on top of his Hoover Junior to kind of build out his proof of concept. And the real key here is that obviously this wasn't the final resolution. He then developed and iterated over and over and over again. And he actually developed 5,127 prototypes of his bagless vacuum cleaner before the first product was ready, which was known as the DC-01. And really, what we also want to see as part of the James Dyson Award is that iterative process. And although we may not expect you all to develop 5,127 prototypes each, we still want to see a prototype being created, and we want to see how we've then resolved future problems that we've then identified. And it's really that ethos that drives a lot of the engineering at Dyson. And we want to see elements of that definitely come across in the James Dyson Award. So this is a nice infographic that loosely demonstrates the problem solution process that we go through as engineers at Dyson. You identify a problem, you have an idea of how to solve that problem, and you need to build and test a solution for that. But then quite often, these will be iterative loops. So although this looks like a nice linear process, the reality of engineering and design is very much a forwards and backwards process, whereby you come up with more problems that you then need to identify before and resolve before coming on to your final solution. And this is really nicely seen and identified in things like the Dyson Supersonic. So for those of you who are not aware of this product, the Dyson Supersonic is a hairdryer that we have designed and developed. And as you can see on the far right-hand side, the finished article looks very, very different to the original conceived hairdryer concept on the left-hand side. And what basically we've done through this is iterated and developed and made the concept better and better, with really the core goal in mind of constant weight in the handle, so that it's a lot easier to manipulate the hairdryer for long periods of use, but also with a real effort on hair heat and also hair health as well. So those are some of the iterative design processes that we implement during our kind of design thinking at Dyson, and how we apply that problem we expect you guys to use in our day-to-day, and what we expect to see hopefully from the James Dyson Award. However, we don't expect to see fully finished concepts like the Dyson Supersonic on the right for all of your entries. So the entry is really easy. You can enter online via the James Dyson Award website. Our requirements is that you must be currently studying or have recently graduated. So we say the past 4 years in an engineering relevant degree from a degree course from a university in an eligible country. So from that map that we showed you earlier. You can also enter as a team if you would like. We say anywhere up to 10 members is our maximum. For the judging criteria, we have a few key set criteria that, as you've probably gathered, is all around the design process. But really, we want an entry that meets the brief. We want to see the solution to a clear problem related to a social, global, or sustainability issue. And we want to see this presented in a really compelling solution. So not only are we identifying a problem, we're also identifying the best way of solving that problem. And really, as with all good design and all good engineering, this has to really improve people's lives. So there has to be a real link back to the user of this product as well. We also want to see how this works. So has the design been really well thought through and well explained? And has it considered things like manufacturing and sustainability as well? We, as I've mentioned multiple times, we want to see that iterative development. So constantly at Dyson, we are thinking about ways of improving products. So we'll launch a product, but we'll be thinking about them, the kind of current products in the background for the next 5 or 10 years. And really, we want to see an element of that. We want to understand how your iterative development process has gone on. And we want to see that you've developed something, but that you've not just sat there and thought that's the best possible solution. You've identified problems with your design and ways that you can improve it and make things better. And for me as an engineer, when we judge the James Dyson Award entrants, that's what's really exciting to us. We want to see the thought process that's gone into the iterative development. We also want to make sure that we also advise that anything that's submitted is really different. And we want to see something that sets your design apart from other products that are on the market. You may be tackling a problem that's already tackled by other products, but we want to see where this particular solution is better than all of those ones. Again, we're not looking for finished products, but we want to see that it has the potential to be a finished product. So don't feel that all of the submissions have to be finished and polished designs. We want to see that process, and we want to see a really strong concept that tackles those problems. So the dates for these are as follows. So the entries are already open for the James Dyson Award this year. And the closing date for those is the 16th of July. On the 17th of September, we'll announce our national winners and finalists. And then on the 15th of October, we'll announce our shortlist before the final international winner and sustainability winner gets announced on the 19th of November.